Hi, everybody. How are you? Good? Okay, this session is very, very oriented to the HDR10 Pros topic. I'm not sure whether you guys are familiar with the HDR10 Pros, but let me give you guys some idea from the scratch to the final more detailed information to generate the HDR10 Pros contents. Okay, basically all the demonstration in here is very, very oriented to the display, like the mobile display or TV display. But the missing part in here is, to utilize the TV or the mobile display, to utilize it as much as possible, definitely you need the contents. So who make the content? That's the starting point of this session. So let me give you the title first. This session is HDR10 Pros Content Generation Tools and the Workflow. If you are expecting something like application development for the mobile device or the TV device with the Tizen application, something like that, it's not related to that kinds of topic. This one is more focusing on contents creation, workflow. Okay. And then my name is Seongnam, and I'm working for the Samsung Research America. Okay. So today, I'm going to introduce those 5 topics. First one is the HDR10 Pros, what it is. Second topic is the technology. So that you can jump in one by one, more deeper and deeper, to get the more detailed information. And the third one is workflow, to create the HDR10 Pros contents. Fourth one is what Samsung is doing, to deploy this solution in the market and how the Samsung is contribute this one to the actual service providers. And then finally, you can get the benefit, specifically better quality of the content. And the last one is one of the example, to make HDR10 Pros content from HDR10. Why I'm saying HDR10 is because that is the baseline of the HDR10 Pros technology. Okay. So let's jump in HDR10 Pros, what it is. Basically, you have to think about why we have to consider about the HDR or HDR10 Pros or something else like a proprietary solution. The reason is you need to get better premium HDR viewing experience. And then currently the matter is whether you can process the content with static matter or dynamic matter. Currently, the most popular one is the static processing, and one of the competitors of our solution, they already start to service the dynamic processing mechanism. So the difference between the static and dynamic means you can handle process the content scene by scene, or only one mechanism for entire movie. That's another way. And also, the benefit of this one is that you can get the more accurate representation with the processing the scene, not the movie itself. Okay? So through this kinds of HDR10 Pros technology, you can get the more brighter, and also you can get the better dark, like a dark shadow area with the original creator intent. At the beginning of this project, when I start this one, our focusing was not improving. Our focusing was more like how we can preserve original creator intent without distortion of the content, because the creator intent, like the movie directors or the original creator, they have their intention. We don't want to distort. We don't want to make our own creator intent through our display. We want to keep their intent, originator's intent, as much as possible. That was the starting point of this project. And then now this technology is broadly adapted in the market at this moment. So a lot of content creators like studios, Warner Brothers, Universal, Fox, Lionsgate, and a lot of content from the Amazon Prime that's available at this moment. Also, we have something like a special program to deploy this technology in the market. And the last point, like extremely cost-effective. I will give you more detailed information about this one through this presentation. And then you can get how you can get the more cost-effective solution through this presentation. Okay. And furthermore, as I mentioned, because this technology is based on the HDR10, this content, HDR10 plus content is backward compatible to the HDR10. Okay, that's also the very important point. Okay. So giving you guys some history about the HDR10 plus. Originally, it was initiated from the HDR10, and there was a lot of discussion to change the content creation mechanism from the SDR to HDR. It was around 2015, and we were looking at how we can improve the quality with a dynamic mechanism, not static mechanism. And then we start something like the contribution, to make it standard. So now is the standard of the SMPTE 2040, and that's the standard. And also the Samsung and Panasonic and Fox built HDR10 Plus LLC, the company, to help this deployment in the market. Now we have a lot of programs through that organization. And also the syntax, even though I didn't mention about this one in here, the syntax is one of the standard of the CTA standard as well. Okay, and then and the interesting is because we start this project from around 2015, we prepared the client device, to support the HDR10 Plus, and then now from the 2016, all the HDR TV from Samsung is support the HDR10 Plus. It's not just an announcement from the new model. It's already there in the market. Okay, and then furthermore, last year we started supporting the HDR10 Plus through the Galaxy, the series Galaxy S10. So earlier of this year, actually we had an announcement to support this technology through the Galaxy platform. So actually there is a demonstration in the booth. So if you want to look at that quality, you can stop by there. So just giving you some brief information about HDR10 Plus LLC. It was established from the 2016, as I mentioned. And now we have a certification center in, for example, in the Korea, TTA, Japan, and America, and China as well. So it has a certification program, which means from the content creation through the entire pipeline with any kinds of process, and then you can get the actual logo, HDR10 Plus logo for your content. And then it's not only the content itself, but you can get the logo for the any kinds of solution like encoder solution or the tool solutions or even device. So you can build that kinds of device with HDR10 Plus certified logo. So just emphasizing about the HDR10 Plus LLC program, that's the actual logo program, and then license program. But it's not royalty program. That's what I want to emphasize. Because you just need a subscription, and you can get any spec and any kinds of information, and then you can build up your solution if you want. And then furthermore, Samsung support you guys to build your solution. And then now the HDR10 Plus has more than 70 adapters. And those are like a lot of companies, and now they are building the contents. So this is some description and the comment for the HDR10 Plus ecosystem. And the industry, like a display industry from the TV, mobile, and the content creator, distributor, and the tool makers, they are all involved in this program. And then tool makers, specifically the software-oriented solutions, these guys are working for to develop the function, HDR10 Plus function inside their tool. So just giving you the very simple summary, like the very short summary of that. So basically, HDR10 Plus itself is the display technology. Now let me give you the more detail about that one through the other presentations. But the idea itself is to make the better quality, the picture on display, you need some special treatment. The reason is it's kinds of mapping, like connecting the content characteristic and display characteristic. So to map that with the best way, you need to figure out. That's the algorithm of the HDR10 Plus. And then nowadays, for example, the subscription fee for the HDR10 Plus is just $300 or $500. It depends on the program. But it's just kinds of minimum payment for the license, not the royalty. And the processing time from the post-production house, it takes much to like 10 times shorter than the other proprietary solution. The reason is when we designed this specific architecture, we were very oriented to reuse previous architecture based on the HDR10, the workflow. So that we could reduce the time and the resources. But the other competitor program is kinds of a toll load program. They want to build a toll gate, and they want to charge money. That's a quite different one. So just jumping in the HDR10 Plus technology, let me give you some technical, some background of that one. Now, previously, when we delivered the SDR content to the display, it was the SDR content. SDR content means you already shrink the content like this one, and then map to the display characteristic. It's already minimized, like shrunk down, and then you cannot preserve the actual the creator intent. But through the HDR content, because it's much wider, that's why they call the H instead of S, HDR, high dynamic range. The range is bigger than the SDR. And then finally, you can get the good content from the display side. But the problem is the display itself, it doesn't have a capability to render this wide range of the contents into the TV system. That's why you need something like a spatial conversion. Conceptually, that's conversion. So input content from here is 1,000 nit. This is just assumption. But your display has a capability to render up to 500 nit. In that case, you need to design some spatial mapping curve with the preservation of the original creator intent. That's the basic concept why we need to develop the HDR tone mapping technology. So the previous context for the the HDR10, like Blu-ray content, that is the most popular content in the market. That has one mapping curve conceptually. I'm saying concept. The reason is because there are so many ways to develop these kinds of mapping mechanism. So what the Blu-ray industry developed was Max Sierra, this one, content luminance level, maximum. They were looking at the maximum number of content luminance, and then they developed the idea how they can map that into, to make the mapping, some change of the content, the pixel values to map into the screen. But the problem of this one is each scene has a different characteristic. So if you apply only this mapping curve for all of these different types of characteristics, you cannot get the maximum benefit of the solution. So this is the idea, to get the better result. So you need to know where is the boundary of the content based on the kinds of scene detection mechanism. And then based on this boundary, you can develop the individual different mapping mechanism. But the problem is that in this case, even though you can generate these different mapping mechanism, you have to deliver the information from the content creator side to the final display side. So you need to develop some mechanism to deliver the information. That's why we call the HDR10 plus metadata. Okay. Also, this HDR10 plus technology is quite different against the other solution. The reason is we have two approaching actually the information. First one is the statistic information, which represent the characteristics of each scene. And also, there is the guided curve we call the OOTF, which means from the content creator side, in order to preserve their creator intent, even they can give like a guide how you can map the content from original to the final display. So from the content creator side, they can keep their mind, like the idea, and their creator intent, and they can verify the quality from the content creator side. And finally, they can send the content with this dynamic metadata, these two information, and then finally the display can get the difference for each scene. So just jumping in more detail in order to deliver the metadata, from the content creator side, once you got the content, what they do is they do firstly the color grading, and they generate the master contents. Once they created the master content, they generated another lot of the different types of content, whatever that is, the SDR, HDR, so many different types of content. But what they do is they encode and finally send that to the display device. Through this process pipeline, what you can do is you need to generate a dynamic HDR10 plus metadata through this process, or even you can generate that through this process, or anywhere before arriving the TV display. So this HDR10 plus technology is much, much more flexible than any others because you can generate the HDR10 plus metadata in any place. So some case, some scene, if this is just the example of one of the scene, so you can get the better brightness and the better darkness in here. So let me give you some idea about the workflow. This is the more in-depth explanation about the mechanism. So once you got the content, what you need to do is currently the market has the workflow to generate the HDR10. So what you need to do is through any kinds of tool, like a DaVinci Resolve or the transcoder, those kinds of tool, you can generate, you can analyze the HDR10 plus metadata, the scene characteristic, and generate the metadata. And then the output of the format is JSON file. So you need to combine this HDR10 content and this extra information, HDR10 plus metadata, while encoding. Or even you can do that, the operation while after encoding. So you can inject the data into the stream after analysis of the content. That's also the easier way. So in order to support this feature, we have collaborated with multiple open source industry community and also commercial solution companies as well. So let me give you just a simple idea about the open source community solution. So now X265 fully support the HDR10 Plus. So because we contribute that and we collaborate with the MCW, the company. So this is one of the example, HDR10 Plus, the word X265, and then also HyperX, because they use the HDR10 Plus technology, X265 technology for their server solutions. And then also we started collaboration with AOM community because they are developing new codec technology, so-called AV1. So we are collaborating with them to integrate HDR10 Plus extension into their main branch, not like the sub-branch, like the extras sources. It's integrated inside their main branch. So once they announce the new version of AV1 codec, it will include the HDR10 Plus technology. Okay. So also, even though I gave you guys some brief information about the HDR10 Plus, also we internally inside the Samsung, we also have a lot of activities to help the industry. So one of that is the command line tool, simple tool, to integrate that into any kinds of workflow. As I mentioned at the beginning, like content, like mastering process or post-production process or encoding process, any OTT service process, anywhere you can integrate this solution as just one function to add one more feature, HDR10 Plus feature. So a lot of command line and tools are available, which is provided by Samsung. So one of the things is the generation, HDR10 Plus, and the injection into the stream, and also there is some very kinds of weird solution, but we also have upgrading solution based on the Dolby Vision, to add the HDR10 Plus metadata on top of the Dolby Vision stream as well. And then we distribute that to everywhere in the world. And nowadays, because we also had a lot of collaboration with Google, the VP9 is already available in the market with the HDR10 Plus. So, and if the solution provider, like a content creator side or the tool makers, if they are interested with integrating this solution into their system, then we provide the SDK for VAD solution and the SDK for live solution as well. So this is the list of the command line tool. We have more, actually we have more, but I just listed only some major command line tools. So let me show you very brief information about the system scenario, why you need these kinds of tool. Firstly, once you got the HDR content, because the purpose of this one is converting the content to HDR10 plus content. But you should not touch the video itself. You just need to analyze the frames and then generate the metadata. So input is the HDR content, and then these tools, it generates the HDR10 plus metadata. And the other scenario is that once you get the video, you need the HDR10 plus video through this processing, right? And the third one is like a TIFF sequence. This is the very common case in the market, specifically for the studio industry. They still want to keep the higher bitrate and better resolution as input. In that case, you need to process that to generate the HDR10 plus metadata. So this is the general scheme of the HDR10 plus metadata generation process. Once you got the contents, you need to process through this mechanism and finally generate. This is just the detail. I will show you a lot of pipelines, details through this presentation, but because that is too deep, I think let me try to skip with just showing the concept, okay, instead of explaining all the steps. So if the input is different, in that case, what you need to do is you need to add extra operation, to inject the generated metadata into the stream. That's another step. And then if that is the image, definitely generated the output with the JSON format. Okay. This is the more detailed information how you can generate the metadata. So once you got the content, like whatever that is, the video or image or whatever, you just need to check whether there's the end of that or not. And finally, you need to figure out where is the boundary of the scene. So you need to activate the scene change detector. And finally, you can know, oh, here is the starting point of the scene, and here is the end of the scene. And then you need to process that for each scene, and then finally accumulate the information to generate the HDR10 plus metadata. So this is the step for each frame, same concept, and then the same concept per scene. The difference of this one is once you generate the statistic information, and you need to accumulate in order to make the one representative statistic information for scene. That is the step. That's why you need to accumulate the information. And then finally, you will get the metadata, where the statistic information, and we call that the OTF, the curve, which was designed based on the Bayesian curve mechanism. And then the other one, this one is also statistic information, which represent 99 point the luminance value and the 100 point of the luminance value. So this one, this information is based on the RGB processing. This information is based on the Y luminance processing. And then this one is guided OTF, to adapt the curve in the TV system or the mobile system, the display system. So now the standard, when we propose this one, there was the mechanism to calculate the Y luminance value. So when we proposed this one to the SMPTE 2940, it had only the RGB-based mechanism, even including this curve mapping mechanism. But now we have all of this one. And this one is driven by the HDR10 plus LLC organization. This is just brief information about new value, Y-based information. Okay. So, to calculate the metadata, after accumulating the frame information, you need to follow these kinds of all the process to get the final metadata. And then the parameters will be here, maximum RGB values and maximum of all of this one. That's kinds of statistic information which represent the scene. And then finally, you can get the percentile information. Why we call, I'm not sure whether you know about the concept of percentile, but if you know about that one, you can easily understand this concept. Percentile is a certain point of the histogram, accumulated information. So this kinds of information is used to generate the HDR10 OOTF guided curve, another metadata of the HDR10. And this is a Y histogram, as I mentioned. And then this is a more detail about the calculation. This is the details what I explained to you for the process. Okay, scene percentile, and then Y luminance values, and then finally generate the curve. And then finally it make the HDR10 metadata. So jumping to the next topic, how you can inject this metadata into the stream. Once you got this metadata, what you need to do is you don't need to touch the video itself, which was already generated through the HDR10 workflow process. In that case, you can keep the exactly same process, and then just you need to add up the HDR10 metadata. So it's a kinds of transcoding mechanism from the encoder-decoder perspective, but the reality is that you need to decode the frame and then process, generate metadata, and inject into the stream. So finally, you can get the HDR10 stream, which is available in the market, and you can distribute to everywhere through any network services at this moment. Okay, and the final thing is the Q&A. And if you have any question about this one, and if you want to know about some detail for some presentation part, please go to the place, the mic, and you can ask your questions. No questions? Oh, yeah, you can go there and ask a question.
Forgive me, maybe you mentioned this, but how long it takes to generate the HDR10 plus metadata? Let's say a feature film. How long would it take in post-production to generate that?
Okay. Typically, the definition of the time in the studio industry, they call the real time. But the actual meaning of the real time is play time. So if the content is a 2 hours movie, they have a mindset like, oh, I want to generate this metadata in 2 hours because the content distance length is the 2 hours movie. This generation takes much, much shorter than 2 hours. Previously, because our solution was not ready to accelerate the operation with the GPU operation, it took so long time, but this time it's much shorter than the actual real time of the content. So let's say if that is the 2 hours maybe, like 30 minutes, yeah, something like that. Okay. Next question. No question. I'm not sure whether you guys get some idea about this HDR10 but if you can see some demonstrations from the booth, you can get more idea.
Thierry Fautier from Harmonic. Can you tell us a bit about live you talk about VOD. Where is HDR10 Plus deployed, or where do you think this will be deployed?
I think your question is 2 points. The first one is the live, and the second one is the current availability in the market, right? Am I right? Okay. And so let me give you the answer for the first one. The live, actually, we had something like a special project with one of the encoder company. And then the goal was very simple. We want to achieve 60 frames per second with 4K HDR10 content encoding. That was the major goal. So based on that requirement, we built a special SDK which can generate HDR10 Plus with feeding the live content, 4K 10-bit content input, and then generating the metadata. And the encoder company had a way to inject. Actually, that is not inject. It's combining with HDR10 Plus metadata and frame with the real-time encoding. And so the FPS is 60 frames per second with the 4K 10-bit PQ processing result. That's the solution. And then specifically for the VOD case, the SDK, we integrate this solution into the most popular tool, like DaVinci Resolve and the ColorFront tool. And also we are collaborating with some of the OTT companies as well to integrate this solution. And then the solutions are now available in the market. So now, for example, the studios, Warner Brothers, they already produce a lot of content, and the Universal and the Fox, major studios in the United States, they already produce the HDR10 Plus content. So it's beyond just the deployment. It's already start producing the content a lot. Okay, is that good enough answer?
Any service, live service?
Live is not there yet, but the VOD is very popular. Yeah, so we are looking for the service provider for the live solution as well. So this solution can be, actually that's one of our project, to promote 8K and HDR10 Plus, AV1, maybe that is involved or not, and then scale-less solution, to reduce the bandwidth. All of the project is based on the technology. We are rolling out the promotions because the technology is already there. So what we need to do is the kinds of deployment program in the market. Okay. Any other question?
Is there anything special the player has to do to play the HDR content?
Yes. The reason is the metadata itself is just metadata. And based on that metadata, definitely you need to build up the tone scaling curve and the tone mapping mechanism. So based on that tone mapping mechanism, once you get the content, you need to convert and finally render that on screen. So definitely you need some special algorithm to do that. And the Samsung helped building up that solution. And then actually the SMPTE 29440, it explains about the idea and the concept. But typically the display companies, when they build up the SoC, the converting from the idea to the actual RTL is not easy. Even though there is a lot of there are many expertise, still it takes time. And then the SoC company doesn't want to make a mistake when they build up the first version of SoC. That's why they come to Samsung to get the reference implementation, and then finally they adapt that into their SoC development. Definitely they need. That's why, for example, Galaxy S10 and the mobile device, they also had exactly the same path, the workflow, to adapt this technology into the display. Okay. Any other question? I have 4 minutes more. No more? Okay.
So, like each thing you have like different bezier like curve for turn mapping like it. So in the turn like scene transition, do you see that the flash is detected or do you have any like in your technology like to mitigate? Because you're seeing like a small transition to put a scene, it detects seeing the transition. So we change the curve that you see that.
Yeah. Basically, the meaning of a scene, it depends on the definition of a scene. Scene represents from one frame to n frame. So how you divide the scene, that's a very important one. So for example, the transition, if we say, like if you have like a 10 frames or 100 frames, that's a scene. But, for example, your question point, like resolve impact, like a smooth transition. In that case, you need to divide that with a multiple scene, or you can treat that with the entire one scene, because you're applying only one statistic information and one curve with the entire this transition time. You don't have any artifact.
So what if like from frame 1 to 100 is like scene 1, then 100 over to 200, another scene. The two curves are different. Do you have that transition curve between the scene boundary or not?
No, you don't need that, because that's the reason why you need to develop the scene change detector. Scene change detector means that you already realized, okay, here is the changing point of the characteristic, right?
It's not manual, means dramatic change, scene change is much larger than turn curve change.
Yeah. Yeah. So if you precisely know about the scene change, it means that you accept the dramatic change. But if you think this is not a dramatic change and you want to keep the previous one, you need to keep the same curve for the next scene as well, right? So that kinds of processing that make the better, the premium visible, like the quality of the picture. So definitely that's a very important consideration, to design the curve mechanism. That's why it's not like the simple mapping solution. That kinds of operation, to figure out, here is the changing, so we need to change, or even there is some change. You need to decide, we should keep the previous curve, like the mechanism based on the previous one. Those kinds of things are one of the algorithms, what we contribute to the market as well. Yeah.
What is the temporal resolution of the metadata? Can you have a different curve per frame at 60 frames a second?
Yes. Extreme case. But usually, the case is based on the scene change point, right? So each scene, like the one-off scene, it has its own metadata or curve, like a statistic metadata or the curve information. So all the information for each frame is same. But actually, when we deploy this one and develop this one, we recommend putting the exactly same information, even that is inside the one scene, putting the same information for each frame. The reason is that, to help the industry workflow, the mechanism, because they can easily cut anywhere, and they can merge. And so the metadata also should be aligned with that kinds of operations. Specifically, the post-production house, they do that kinds of activities a lot. So you need some way, and we realize because our metadata is not big, because it sends only kinds of coefficient data, anchor point information of the Bayesian curve, and the statistic information. It's good enough to put that into every frame. So it's not burden at all. That's why we decide, okay, let's put everything for every frame. Okay.
For metadata generation, is it for scene or the actual
Basically, the generation is per scene, but you put that into every frame. Okay?
You mentioned that you can inject the metadata or generate it at any stage of the pipeline.
Yes, right.
Have you compared kind of what the quality difference is between doing it from the source material to like the final encode?
Yeah. Basically, that kinds of difference came out from the source, the quality. For example, the original quality from the master content, that is the 16-bit RGB data without any compression. But if you generate that at the end of the OTT service, in that case, it might be just 10-bit, right? Because this is HDR, we are not talking about 8-bit. So the 10-bit content. But if somebody misoperate the encoder, in the case that the quality is so horrible. In the case, the quality based on that content, the information, you cannot get the maximum benefit. But definitely generating that from the post-production house at the beginning, that's the best. But the quality different, because this is the extra information to get the more benefit of the quality. Wherever you generate that one, still you get better than HDR10. That's the point. So you get the additional quality benefit, not losing anything. Okay? Yeah, I'm done. 0. Okay, thanks for coming, and hopefully you enjoyed this presentation. Thanks.